Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is to cover about chapter 7.1, the parabola. Okay, so in this chapter, student need to find the equation of parabola in standard form and general form. Second is to sketch the graph of parabola. Third, find the equation of tangent to parabola at a particular point. Okay, so let's first we look at the graph of parabola to identify the components that we have in parabola. Okay, so let's see here. Okay, the black line here is the locus of the parabola. Okay, this is the shape of the parabola. Okay, this is the parabola. Okay, so in parabola, we have a few components that we need to identify. So this dotted green line is called as the directrix, okay, which will appear in front of the parabola. Okay, this the purple dot is called as the vertex, and the green dot here is called as the focus point of the parabola. Okay, so the identity of a parabola is that the distance between the focus and the vertex will have the same distance from the vertex to the parabola. Okay, okay, let's label the distance between focus and the vertex with a letter P, and then from vertex to directrix we will also have another letter P because it is in the same distance. Okay, so in order to have a shape of a parabola is drawn based on this concept. Okay, the concept is the distance between the focus, okay, the distance between the focus right here from this green dot to the point on a parabola must always be equal in distance between to that point to the directrix, okay, which is right here, this dotted orange line. Okay, now let's say this is as the distance m, okay, between the focus to the point on the parabola is labeled with the distance of m, and a point from the parabola to the directrix is also at the same distance, can also be labeled as distance m, and the angle between the directrix and the green dotted line and this orange dotted line must always be 90 degrees. Okay, so let's look at this simulation. So right here we have the same parabola graph. Okay, we have the focus right here, the vertex, the green dot is the focus, and orange dot is any point on the locus of the parabola. Okay, as you can see here, we have another green dotted line which is called as the directrix. Okay, you can see the distance between the vertex and the directrix must always be at the same distance. Okay, as the same distance from the focus to the vertex, which is the purple dot. Okay, let's say if I move the position of the focus further away from the vertex, you can see that the directrix will also move away from the vertex because they want to be in the same distance. The vertex must always be positioned in the middle, in between of focus and directrix. Okay. Okay, so now if I move the green, if I move the orange dot, okay, if I move this orange dot, you can see the dotted orange line will always be in the same distance from the green to the orange and the orange to the directrix. Okay, that is the main main identity to draw a parabola. Okay, you can also observe that the angle between the directrix and this orange dotted line always in 90 degree of angle. Okay. Okay, so now let's look at this example of a parabola. Okay, now I want to label the position of focus. So this green is the focus, the purple as the vertex, and the dotted green line as the directrix. Okay, then this green is actually any point on the locus of parabola. So I want to label that as a capital P, which represent the point. Okay, so since we already know that the distance between the focus to the vertex is actually the same distance as from the vertex to the directrix, and which is labeled as the small letter of P, okay, lowercase of letter P. Okay, so since we have the vertex and the directrix, the distance is equal to P, and since this parabola, its vertex is positioned at the origin of the plane, okay, at the point of 0, 0, and we know the directrix will be equal to negative P. The line of directrix will be equal to negative P. Okay, so we also know that the distance between the focus to any point on the locus on parabola is the same distance as the point P to the directrix. Okay, now we want to create a right angle triangle from F to this orange line, orange dotted line. Okay, so we know that FP will be equal to PD. Okay, so now let's label position of point P as X and Y. Okay, we label that as X and Y. Okay, so we know the Y is actually comes from this great distance, and the X will come from this distance. So then this will be the X, and right here the length between this point will be Y minus P, minus the distance between vertex to the focus, and then we will know the length between FP will be equal to Y plus P. Okay, so from that we can create a Pythagoras theorem where we will have x squared plus y minus p squared equal to y plus p squared. Okay, x squared plus y squared minus 2py plus p squared equal to y squared plus 2py plus p squared. Okay, so we can remove a few things from here. Okay, then you can see we now have equation of x squared equal to 4py. So this is what we call as the equation of parabola. Okay, so this component, we can see the small capital of P is actually represents the distance between the focus to the vertex, and also the distance between the vertex to the directrix. Okay, what we want to see here, we have a component of x squared, which is actually equal to the graph of quadratic function, because we also can see here that the graph of parabola is also as the same has the same shape of a quadratic function. Okay, so we have two types of parabola. Okay, where the first type is where the parabola that opens horizontally, and we have another type of parabola that opens vertically. Okay, so for parabola A and B, we can see that this is a kind of parabola that opens horizontally, because we can see this side where it opens is on the horizontal position. And for parabola CD is a parabola that opens vertically. We can see this area is where it is open for this kind of parabola. Okay. Okay, then for parabola A and B, okay, for parabola A and B, we can see the equation for the parabola is quite different from the parabola for C and D, where the equation is y square equal to 4px, and then for parabola C and D, the equation is x square equal to 4py. Okay, so in order to make us easy to memorize this kind of thing easier, okay, for matrix, for parabola A and B, okay, where it's open on the horizontally, okay, y square equal to 4px, okay, you can change this equation into y equal to square root of 4px. Okay, so when in an equation we have x that have a square root on top of it, so you know this is a kind of square root function, where a square root function will be shaped like this. And meanwhile, for parabola C and D, where the equation is x square equal to 4py, which is actually almost similar to a y equal to x square, which is a quadratic function that has open side on the open side vertically. Okay, so that is how you can differentiate these two kind of formula for these two kind of parabola. Okay, so now let's look at an example. We want to find the focus, directrix, and vertex of each of the following parabolas. Okay, for question A, we have equation of x square equal to 16y. Okay, so firstly, we have to identify whether this parabola has open side horizontally or vertically. Okay, so first we observe at the equation. So this is x square equal to 16y. Okay, where the position of square is located with the x, so which has the same shape as y equal to x square, a quadratic function. So you know a quadratic function has open side vertically, so we know we can sketch our graph as like this. This will be our first estimation of our parabola, which has open side vertically. Okay, so this is a parabola, so we know the equation of a parabola is x square equal to 4py. So next is to identify the value for p. We want to identify the value for p. So right here we have 16. Okay, so the 16 will be equal to 4p, and we can say that p is equal to 4. Okay, so now we know the position of our focus and directrix from our p. So this will be the value of p, and this is also the position of value of p. Okay, then from vertex to the directrix has the length of p, where p now is equal to 4. Okay, then we can say the directrix is equal y equal to negative 4. And then the focus of our parabola, we has a position above 4 from the vertex. So the parabola, the focus will be right here, where the position of 0 and 4. Okay, so we can write down that the focus equal to 0, 4, and the vertex is at the origin of our graph. Okay, now let's look at another example. Okay, for question B, x squared equal to negative 16y. We have a negative value here. So this is equation where y equal to x squared. But do not forget the negative. The negative can also be bring on to the left side, and which shows us a negative quadratic function. So y equal to negative x squared. So from that we can know our graph of parabola will have open side on the negative area. Okay, this is our parabola, and don't forget to label the y and x axis. Okay, then we want to identify the value of p. So x squared equal to 4py. Okay, so we want to find the value of p. So we take 4p equal to 16. Okay, just take 16. Don't have to take the negative number. So the negative is actually show whether the parabola opens on the positive or negative region. So now we have p equal to 4. So this will be the position of p, and this will be the position of p. So from that we can draw the line of directrix. So now our directrix, the equation will be y equal to 4, and our focus will be 0, negative 4, and our vertex will be at 0 and 0. Okay, another example, example C, y squared equal to 4x. Okay, so from here, this is equation of parabola, where now the square is placed with the y. So y squared equal to x. This is just for example, okay, for you to easy to identify whether the parabola open the open is vertically or horizontally. So y squared equal to x. So we have y equal to square root of x. So that means this is the shape of the parabola will be almost the same shape as the square root function. So now we know that our parabola will be open on this side, since it open must be with the same shape as the square root function, and the equation is also a positive. We want to identify the value of p, so we can say that 4p is equal to 4, and now p is equal to 1. So we know that the distance between the vertex will be 1. So this is the focus, p, and right here we also have another p, where the equation of directrix. Okay, so now we have a directrix with equation where x equal to negative 1, and then for focus will be 1, 0, 1, 0, and the vertex for this parabola will be as 0, 0. Okay, now let's look at example number 2. Y squared equal to negative 2x. Okay, so y squared equal to x, y equal to square root of x. Okay, this has a parabola where its shape as the same as a square root function. And since we have a negative 2 right here, so our parabola opens to the left. Okay, alright. So we want to identify the value of p. So 4p equal to negative 2. Sorry, don't need to have to take the negative. Just take the number 2. So 4p equal to 2 and p equal to 1 over 2. Okay, so this is the position of p. And right here we will have our directrix and focus point. So directrix now is equal to 1 over 2, 0. And then for focus point is the negative 1 over 2, 0. So just write down here, focus is negative 1 over 2, 0, and our vertex stay as at the origin of our graph. Okay, now let's look at 7.1.3, where the equation of parabola, where the vertex is now not located at the origin of the plane. Okay, so let's look. Firstly, we focus right here. So this is the parabola where the origin is located at where the vertex is located at the origin. We have v00 where the vertex is at coordinate 0, 0. Okay, so now let's, for example, let's move the vertex to a position of hk. So vhk as written right here, vhk. So what it did to the equation of the parabola is that it will change the y and the x component. So where the initial equation of parabola, we will have y equal y square equal to 4px, where the vertex at origin. Now, if vertex is moved at the position of hk, and then the equation will become y minus k square equal to 4px minus h. Okay, this will be the new equation of a parabola where the vertex is not at the origin. Okay, now from that, because of the changes of the position of the vertex, it will also affect the position for focus and directrix. Okay, it will also affect the position for focus and directrix. Okay, so in this parabola where opens on the horizontal, okay, so now we can see that the focus now become fh plus p. H plus p k, because where at the original parabola where vertex at origin, we will only have f equal to 0 p. So now it will be h plus p k. Okay, now I spot a typing mistake right here. The focus actually not 0 p, but it's actually f focus p0. Okay, please make this change into your reference book, not f0p. Okay, now the new focus point is fh plus p k. So now for parabola which opens vertically, okay, where the original position, the original equation for parabola is the x square equal to 4py. Now, when the vertex is moved to a certain position, okay, where the vertex now become hk, then the equation for parabola will be x minus h square equal to 4py minus k. Okay. So now we have a new position for vertex. Vertex will be the hk. Then the focus point will be hk plus with the p. Okay, now this is the equation for focus. And now the directrix will be y equal to k minus p. And the vertical symmetrical axis will be x equal to h. Okay, let's look at an example. Okay, find the vertex, focus, and equation of the directrix of each of the following parabolas. Okay, for example, we have equation A. So, given that equation A is x minus 2 square equal to 8y plus 1. Okay, so from the equation, when it written as x minus 2 in a bracket of square, and then y plus 1 is also in a bracket. So, at the first glance, we can see that this equation is actually a parabola where the vertex is not at the origin. So, in order to find the position of the vertex, we just take each of the bracket. So, x minus 2. Now make it equal to 0. So, x equal to 2. So, then y plus 1 make it equal to 0. So, y equal to negative 1. So, from here, now we can say that the vertex is equal to 2 and negative 1. Okay, that is how easy you can determine the vertex from the equation of parabola. Okay, then the equation of the parabola given mention that the square is actually placed with the x. Okay, the square is with the x, so it's just the same as y equal to x squared. So it's a positive one. So then we know our parabola actually opens vertically. Okay, now we have the vertex is at 2, negative 1. So 2 and negative 1. So this is the position of vertex. Okay. So now we know our directrix must be lower than the position of vertex. So in order to find the directrix and the focus point, we have to find the value of P. So for P is equal to 8. So then we have P equal to 2. So then for directrix, the equation of directrix will be y equal to, the vertex here is negative 1. Okay, then we take a negative 1. We minus 2 because it must be lower 2 points from the vertex. So that will be a negative 3. So this is our equation for directrix, y equal to negative 3. And then for the focus, we take the coordinate for vertex. It will be 2, negative 1 plus 2, and then our focus will be 2 and 1. Okay, so this will be the focus, 2 and 1. So that is how you find the vertex, directrix, and focus for a parabola where the vertex is not located at the origin. Okay, so now let's move to another example. We have x plus 4 square equal to negative 20, y plus 1. Okay, so from here, we can identify straight away this is a parabola where the vertex is not at the origin. So now we want to find the vertex. So x plus 4, make it equal to 0. So x equal to negative 4. Y plus 1 equal to 0. So y equal to negative 1. So straight away we can say the vertex is at negative 4 and negative 1. Okay, so now we identify whether the equation of the parabola is a parabola that opens vertically or horizontally. So this x square. So now we have x square equal to y. So this is y equal to x square lah. So now we know this is a parabola where it's open vertically with a negative sign right here. So now we can draw that since the vertex is at negative 4 and negative 1. So this is the vertex, negative 4 and negative 1. Okay. So next we want to identify the focus and the directrix. Okay, so we have 4, P equal to 20. So now P is equal to 5. So then our directrix will be y equal to negative 1 plus 5. So y equal to 4. So this is the equation for directrix. And then for focus, we take the coordinate for vertex, negative 4, negative 1, then it will be minus 5. So then negative 4 and negative 6. So this is the position for focus, negative 4 and negative 6.